This is your first video of the course, and it's going to be a review. We're going to be reviewing function notation and adding and subtracting polynomials. Not necessarily related topics, although you will see polynomials within functions. But we do need to get this function notation down because you're going to see a lot of functions in this course. You should have done it in Algebra 1. If you didn't, or you don't remember, well, that's why we're doing this now. So I have the first couple sentences here. You'll see most higher level math is built upon the concept of functions. So basically, it is important to know the definition of the function, which is any rule. So you got to think of a function as a rule that assigns exactly one output value for each input value. Okay, so you can kind of think of a function as like a machine, and then that's what I have on the next slide here. Actually, is this function machine, and the function is in this case 2x plus 3. That's what you want to do. That's what you're going to do, and you need an input value. In other words, you need to know an x value to input into that machine, and then it's going to output some other value. So you've done functions. You've definitely done functions. You just may not have called them functions. You certainly all know how to take y equals 2x minus 3, for example, which is our function in this case. Y equals 2x plus 3. And then if I told you what x was, you would know how to plug it in. So in this case, see how x equals 4? So the function says, all right, y equals 2 times 4 plus 3. And that gives you y equals 11. Okay, so basically, you have an input value of 4, and you have an output value of 11. That's what this function does. Now, this example doesn't have function notation, but here you start to see function notation. Now, this f parentheses x, and the g parentheses x, and the h parentheses x. If you don't remember this, I just want to talk a little bit about what this notation is. So first of all, you see this f parentheses x, for example. Okay, f is the name of the function. Okay, I just want to make sure. Yeah, I don't have that here anywhere. Okay. Oh, there it is right here. I knew I had that. So f is the rule. It is the name of the function. So the rule is, you could think of as the name of the function. And every function has a name. It has f, g, p. It can be called any letter. So that's the name of the function. Whatever comes after the rule, whatever comes after the name, that's just the input value. So it's normally an x. Almost always you're going to see x. So it's f of x. And the way you read this is, so this here, f parentheses x, is read f of x. So the parentheses, you say the word of, okay? F of x, function of x. So f is a function of x. X being and think of x as the input and y as the output. So whatever you get here for an output value, that is actually the y value. So if you go back to what we did here, we had an input of 4 and an output of 11. That means when x equals 4, y equals 11, and therefore the point 4, 11 is part of our function. All right, and then we're going to talk more about that. So here is basic functions, and we're going to evaluate. So just to get you used to the notation. So we have that this is function f. Okay, here's function g. Here's function h. In function f, my input value is x, and this is the rule right here. So here's the rule, 5x minus 2. That's what we're going to do when we know what x is. Well, here, this one here says f of 3. So what happened was, if you notice, the x comes out and the 3 was put in. It was substituted. It was replaced. So the x was replaced with a 3. So what do you think we'll do over on this side of the function, we will take out the x and put in a 3. So it's going to look like this. 5 parentheses 3 minus 2. And that's going to equal what? Well, 5 times 3 is 15, minus 2 is 13. It's that simple. F of negative 2. So now the x is replaced with a negative 2. We just plug in input of negative 2. And then minus 2. Because that's part of the function, 5x minus 2. 5 times negative 2 is negative 10. Minus 2 more is negative 12. So we get negative 12 for our output. Okay? So we input 3, we get an output of 13. Input negative 2, output negative 12. So x is 3, y is 13. When x is negative 2, y is negative 12. So now we'll go over here. Okay, 3 goes in for x. 3 parentheses squared plus 4. That's 9 plus 4 is 13. And then 0 squared plus 4 is, of course, just 4. Moving on, we talked about that. Now I just want to practice some other types of questions you might see and other ways to think about input versus output. So we have the input is the independent variable, which is the x, typically the x value, but it doesn't have to be x. In this case, look at this example here. They're calling the function t, capital T, of h. Here is the function right here. I don't even have an equation this time. It doesn't matter because they gave you all the values. They gave you all the data values you're going to need to answer these questions. Evaluate t of 2. So let's think about this now. The function is t of h. That means t is the name of the function, temperature. That's why they call it t. H is the independent variable. H is the variable that you're plugging in to the equation, if you had the equation. But h is the input value. So what they're saying is to evaluate t of 2, that means 2 is now the h value. So what we're going to do is say, all right, well, where's t of 2? Where's my h value of 2? Everyone knows how to read a table? Here's my h value of 2. I'm going to highlight that, maybe. Highlighter, where are you? Oh, there you are. Okay, highlight 2. That's the t of 2. And they're asking you what would asking you to evaluate it. So what's the value of the function? The value of the function is t of h. T of h is the value of the function. Here's t of h. Here's all my t of h values. So the top row are all your input values, and the bottom row are all your output values. So when I have an input of 2, what's my output? 104. It's that simple. So this is going to be 104. T of 6 right here. What's my output value, my evaluation? 68. How could it be that easy? It is. I'm just trying to get you to understand the relationships here. For what value of h is t of h equal to 76? Now they're giving you t of h. T of h equals 76. Well, where does t of h equal 76? Where does t of h equal 76? Right here. Okay? Oops. T of h equals 76 right here. Okay? So, what is the value of h? The value of h would be 4. So, h equals 4. That's it. So this would be t of 2 equals 104, and t of 6 equals 68. And t of h equals 76, so h equals 4 when that's the case. See the relationship x, y? It's basically x, y. But instead of y, it's the function t of h. The function t based on h. They're telling you the variable in parentheses. All right. So next exercise. Now we're looking at functions on a graph. Okay, so evaluate each of these using a graph. So by now we understand that whatever is in parentheses is the x value or the input. So we're using a graph. Let's start thinking of these as points. X, y, x, y. So for f of negative 1, I know that, I'm going to put equals and we'll leave it blank, but I know that that's the point negative 1 something. the point -1 something. Why? Because -1 is the x value. The input is the x. So if -1 is the x value, I'm going to go over to my graph. Where is x -1? X is -1 right here. This is where x is -1 at all these points. So where is the function actually hitting that? Well, the function is actually hitting that right here. Let me change colors. Right there. And that is at 0. The y value is 0. So -1, 0 is the value of f of 1. Let's do another one. They want you to evaluate f of 1. F of 1 equals, okay, well, I know the x value is 1. Where is x equal to 1? Okay, x is equal to 1 right here. All along that line. Where does it hit the function? It hits the function right here. And what's the y value right there? 1, 2, 3, 4. So y is 4. Therefore, f of 1 equals 4. So you get it? X, -1, y is 0. X is 1, y is 4. I want you to get used to this notation if you haven't already gotten it coming in. F of 5. Okay, so where is it? 5. 1, 2, 3, 4, 5. Right there. And that's where it hits the actual graph. And that's at -1, 2, 3, 4. -4. So -4. So we could say 5, comma, -4. Very Christmassy here, right? All right. Very good. Evaluate f of, let's see. Okay. Evaluate f of 0. What special feature on a graph does f of 0? All right, so f of 0, that means x is 0. X is 0 right here. And where does it hit? It hits right here. 1, 2, 3. So f of 0 equals 3. That's the point 0, comma 3 if you were to graph it. That's this point right here. What special feature does it correspond to? Well, what do you think it is? What do you think this would be? What is this representing right here? This 0, comma 3. What is this known on as the graph? What's it doing? Where's it hitting? It's hitting the y-axis. This is known as the y-intercept. And solve values of x, or what values of x? Solve the equation f of x equals 0. F of x equals 0. F of x is the y. Okay, so the y now equals 0. Where does y equal 0? Well, y equals 0 on the x-axis. This is where y equals 0 because you're not going up or down. It's a level, okay? And so where does it equal? It hits a few different points. In this case, it hits here, it hits here, and it hits here. So what values? It says values. There's more than one. -1, 1, 2, 3, and 4, 5, 6, 7, and 7. -1, 3, and 7. And what special features are these? Well, it's hitting the x-axis, so these are called x-intercepts. Okay, make sure you're taking good notes here. For a function y equals g of x, it is known that g of -2 equals 7. Okay, so there we go. Here's our x, and here's our y. X, y. Which of the following points must lie on the graph? Well, we got it right there. -2, 7, x, y. Just another way of asking the same thing over and over again, right? And last one here, then we go on to our addition and subtraction. Physics students drop a ball from the top of a 50-foot high building, model its height, function of time with the equation h of t right here. This is our equation. All this wording is in the equation. You don't have to worry about that. Determine the height of the ball after 1.5 seconds. What's the 1.5? Is it time or is it height? That's what you got to determine. 1.5 seconds, is that time or height? I think you realize that it is time. Seconds is time. So t is 1.5. So therefore, I'm going to do h of 1.5, and I'm going to do 50 minus 16 times 1.5 squared. And just put that in your calculator, which I already did to save time on the video for you, and it comes out to be 14 feet. Okay? Now, I'm getting a little long. I don't want to have really long videos here. I'm trying to keep them close to 10 minutes. I know we're getting a little long this one here, but if you just, I want you to pause it and just read these over. There's examples here for adding, subtracting polynomials. You can do them horizontally or vertically. I showed you this example here. I showed you it horizontally and vertically. They're already done. Here we go. So this one here, we'll do these vertically. This one I'm not going to do vertically just because it's adding. I'm just going to circle the like terms. 2x squared and 5x squared, that's 7x squared. And then we got an 8x and a negative 2x, and that's positive 6x. And then we got a, oops, what did I just do? Okay, so 7x squared plus 6x. And then negative 1 and negative 8 is negative 9 when you add them together. Okay, so that is that one there. So this one here, we'll do it vertically. We got the room here. And we have a subtraction. This is we got to do something first. So we're going to change all our signs. We're going to make this a plus. Then we're going to make this a minus, make this a minus, make this a minus. So that negative distributed through, basically. It's like there has a negative 1 in front there. Okay, so now we're going to say, all right, we have negative 5x squared. You got to be very careful with these. Negative 5x squared minus 2x plus 10. And then here we're going to say plus negative x squared. Now we don't have to worry about any distributing because we already did it. Minus 7x minus 5. Now, so you change all the signs, then do it vertically. Now, it's nice and clean. You're just combining like terms. A negative 5 plus a negative 1, there's a 1 there, is negative 6x squared. And this is negative 9x, and this is plus 5. So, pretty simple. I know you guys have done this before, so hopefully you're well versed here. This one, another subtraction, so we're going to go plus, minus, plus. Okay, so we're gonna, and now here, the lining up's a little trickier here. We have cubed, so we got 2k cubed. You want to make sure everything lines up. We don't have any k squared here, so we're going to put plus 0k squared, and then plus 5k, and then plus 4. Okay, plus, now we got 7k to the third, 7k to the third, and then minus 5k squared. Notice how I don't care about the order. I can rearrange the order as long as I keep the sign with it, the right term. That negative goes with the 5k squared. I don't have any k, so plus 0k here, and then plus 2. So I have 9k to the third. I have a negative 5k squared. I have 5k and 0k, which is 5k. And then I have 6. Hope I didn't go too fast. We will do that one together. I'm going to have you try it in class, and then we'll do it together tomorrow. I will see you then, and we'll practice all these skills and a lot more. Don't worry if you didn't get it perfect on this video. That's okay. You're just taking this information into class. You're going to learn it a lot better in class when you're working with your classmates, and I'll be around to help you throughout the day. Hope you enjoy the class. Hope it wasn't too much for you, and I'll see you tomorrow.